Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss multiplexer. Let's begin. For data processing in computers, we use a logic circuit. Basically, that logic circuit is known as data processing circuits. There are various kinds of data processing circuits. Examples of data processing circuits are multiplexer, demultiplexer, decoder, encoder, etc. Here we discuss about multiplexer. Multiplexer is a logic circuit that accepts several data inputs and allows only one of these inputs at a time to get to that of output. That name indicates multi. Multi means many, or we can say more than one. Multiplex means many into one. So it has several data inputs, and at output only one output. In short, we say it as MUX, MUX. It is called as the data selector. Data selector because it chooses one of the many inputs and sends the information to that of output. When we use the multiplexer in an electrical circuit to show it diagrammatically, we prefer the block diagram of a multiplexer. That one is a multiplexer. Select lines with the select signals. Input signals n number of input signals, but we have one output signal 1. That is a typical block diagram of n to 1 multiplexer. N to 1 multiplexer. So, what are the maximum number of inputs allowed? That is decided from that of select signals. So, in general Here is the block diagram of n to 1 multiplexer. So, in general, multiplexer will have a provision for m number of select lines, then the maximum number of input signals, then the maximum number of input signals allowed is equal to 2 to the power m. So, here the input signal, therefore, the input signal line n is equal to 2 to the power m. Example, if we select 1 out of 4 input lines, to select 1 out of 4 input lines, then there will be the number of select signals will be 1. There will be 2 select lines are provided. Therefore, we have 2 to the power 2 is equal to 4. If we select 1 out of 8 input lines, so we have to select 3 select lines are provided. As we say, 2 to the power 3 is equal to 8. Therefore, 3 select lines are provided to get 3 inputs as 8 inputs to take 1 output. On this basis, we categorize the multiplexers. Here we discuss about 2 multiplexers as 4 to 1 and 8 to 1 multiplexer. First, 4 to 1 multiplexer. According to that of select lines, what be the number of inputs to that of output? The multiplexer are named. So, the name indicates 4 to 1 multiplexer means the logic circuit that accepts 4 data inputs and allows only one of these inputs at a time get through that of output is known as 4 to 1 multiplexer. In that of block diagram, it has 2 select lines, are named as let S0, S1, that is the select signals, so the input signals are the 4, 1, 2, 3, 4 input signals. These are named as D0, D1, D2, D3. These are the input signals. And output Y as output, that is a 4 to 1 multiplexer MUX, 4 to 1 multiplexer. This one is the block diagram. Now the truth table for 4 to 1 multiplexer, the data selection inputs, data selection inputs, as S1, S0, S1, S0, and output we have Y. So the possible inputs as 0 0, 0 1, 1 0, 1 1. So at output section, from D0 to D3, D0, D1, D2, D3. This is the truth table for multiplexer 4 to 1 multiplexer. The truth table for 4 to 1 multiplexer. From that of truth table, we can have the Boolean expression. From this truth table, so the output Y, data output Y. Look here, for 0 we use primed, for 1 we used unprimed. D0, so in that of section output Y, D0, X0, S1, for 0 0 D0, 0 0 D0. So for 0 we write prime symbol, S1 dash, write it D0, D0, S1 dash, S0 dash, plus next D1, here 0 1, so S1 dash, S0, plus D2 1 0, so S1 S0 dash, plus D3 as S1 S0 dash. That one is the Boolean expression from that of truth table. By using that Boolean expression, we can easily construct the logic circuit for 4 to 1 multiplexer. To use that logic circuit, from that Boolean expression we have to draw 4 AND gates, 1 2 3 4 AND gates. It has the inputs D0, D1, D2, D3 accordingly. We take the inputs. Inputs are D0, D1, D2, D3. So selection line S1 and S0. S1 line first we draw that of S1 line let. Next S1 dash, use a NOT gate, that line for S1 dash line. Next S0, that line for S0. For S0 dash, use a NOT gate here, that line basically for S0 dash. Now first D0 S1 dash S0 dash. So D0 S1 dash S0 dash S0 dash. Okay. Next D1 S1 dash S0, D1 S1 dash, that is the S1 dash line, S1 dash. Next S0, this is S0 line. Next D2 S1 S0 dash, D2 S1 S0 dash, this is S0 dash. Okay. Next D3 S1 S0 dash, D3 S1, this is the S1 line, S1 line S0 dash, S0 dash. The output of these AND gates are the inputs towards a OR gate. The outputs of these AND gates are the inputs of OR gate. Therefore we achieve that Boolean expression. These are the inputs. Okay, this is the logic circuit for 4 to 1 multiplexer. 4 inputs and 1 output, 4 input signals and 1 output signals. For that of 4 inputs we have to select 2 select signals, that is the truth table for 4 to 1 multiplexer. From truth table we get the Boolean expression. From that Boolean expression we construct that logic circuit for 4 to 1 multiplexer. Another type of multiplexer as 8 to 1 multiplexer. As its name indicates, an 8 to 1 multiplexer is a logic circuit that accepts 8 data inputs, that allows only one of these inputs at a time to get through that of output. We can easily show it by using its block diagram. For 8 inputs we have to select 3 select signals. Select signal lines are 3. Select signal lines are S0, S1, S2. These are the select signals. Data inputs, 8 data inputs, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 data inputs named as D0, D1, D2, D3, D4, D5, D6 up to D7. These are the data input signals. And output, one output Y. This is a 8 to 1 multiplexer. That is a block diagram of 8 to 1 multiplexer. From that of block diagram, we can achieve the truth table. The truth table for 8 to 1 multiplexer: first, data selection inputs, data selection inputs, data selection inputs as S2, S1, S0, S2, S1, S0. So, the output, we have one output Y. So, the possible selection inputs as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. At output, that is D0, D1, D2, D3, D4, D5, D6 up to D7. From that of truth table, we can easily construct the Boolean expression. From that truth table, the data output Y is equal to, look here, D0, S2 0, S1 0, S0 as 0. For 0 we use prime, for 1 we use unprimed. That is why it will be D0, S2 dash, S1 dash, S0 dash plus D1 as S2 dash, S1 dash, S0 plus D2 as S2, S1 dash, S0 dash plus D3 as S2 dash, S1, S0 plus D4 S2, S1 dash, S0 dash plus D5 S2, S1 dash, S0 plus D6 S2 S1 S0 dash plus D7 S2 S1 S0, all three are unprimed. That is the Boolean expression from that of truth table. That truth table for 8 to 1 multiplexer. This is the truth table for 8 to 1 multiplexer. Now we can construct the logic circuit for 8 to 1 multiplexer by using that particular Boolean expression. First, we construct it by taking h number of AND gates. So 8 number of AND gates are chosen. 8 number of AND gates: 1, 2, 3, 4, 5, 6, 7, 8 number of AND gates are chosen. Each AND gates, we have the inputs that are the inputs as D0, it is the input, D1 the input, D2 is D3, D4, D5, D6, D7. Next, we have S0, S1 and S2. For this we select let S2, that for S2 line. Next, we have to choose S2 dash. We use a NOT gate. It's selected, that for S2 dash line. Next, S1 line. When we select a NOT gate is used, so that line is for S1 dash line. Next, S0 line. Next, a NOT gate is used and that line is chosen as S0 dash line. For first one, D0 as S2 dash, S1 dash, S0 dash. So S2 dash, S1 dash, S0 dash. Next, S2 dash, S1 dash, S0. S2 dash, S1 dash, this is the NOT line, S0, this is the S0 line. Okay. Next, S2, S1 dash, S0 dash, S2, S2 line, S1 dash, S0 dash, S0 dash. Okay. Next, D3 as S2 dash, S1, S0, S2 dash, S1, S0. Next, D4 S2, S1 dash, S0 dash, S2, S1 dash, S0 dash. For D5 S2, S1 dash, S0, S2 S1 dash S0 S0 for D6 S2 S2 S1 S1 S0 dash, this is the S0 dash line. Next for D7 as S2 S1 S0. In this way we have provided the inputs. Next, the outputs of all these AND gates are the input towards a OR gate, and finally we have the output Y. These are the inputs towards that of OR gate. This type of logic circuit is known as logic circuit for 8 to 1 multiplexer. So, with the help of this video lecture, we understand the concept of multiplexer, discussion about two kinds of multiplexer as 4 to 1 multiplexer, its block diagram, truth table and its logic circuit. Another multiplexer as 8 to 1 multiplexer, its block diagram, truth table and Boolean expression. From that of Boolean expression we construct the logic circuit. So, with this useful and informative notes, let me wind up this session. Thank you.